Hello, Noel physicists. It's Miss Rose. I'm going to be teaching you about scientific notation. I know that you need it in your physics class this year. You also need it on NWEA. So let's get to work. Okay. So why even is there scientific notation? Well, it's a way for scientists to communicate without using gigantically big numbers or gigantically small numbers, or numbers that have many, 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 many zeros. It's a way to be more exact about what you're discussing and to make it easier for different scientists to interpret, okay? So let's take a look at what scientific notation looks like. I'm going to write a number, and you're going to tell me, is this scientific notation? Ooh. Is 7.1 times 10 to the 3 scientific notation? Yes. Why? Here's what scientific notation has. The number here in front of the decimal place is one digit. It's the number 1 through the number 9. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, but it can't be 10 because that's two decimal. That's two places in front of the decimal, okay? So it's one place in front of the decimal, and then we have times 10 and some exponent, okay? So what does this actually mean? Well, what it means is that you are going to take this number and you're going to grab this decimal place and you're going to move it 3 places to the right. So let's grab it and move it. 1, 2, 3. Now you're going to put the decimal place here. And instead, we're going to put zeros in this place. So this number really means 7,100. That's what that means. Okay? There it is. Again, one digit, a single digit in front of the decimal. Okay? Let's try another one. 8.374 times 10 to the 7th. Again, we are going to take this number, 8.374, excuse me. We're going to grab that decimal point and we're going to move it 7 places to the right. Okay? 1, 2, 3, 4, 5, 6, 7. And these are all going to be zeros because there's no other numbers there. And so this number really is 83 million. Oh boy. 740,000. Wow. There it is. Okay. Now these were positive numbers, positive exponents. But what if you had a negative exponent? What if we did the number 4.321 times 10 to the minus 2? Well, the minus now is telling us to move this decimal place 2 to the left. So again, we're going to grab the decimal and we're going to move it the number of places we need to, as determined by the number, And the direction is given by whether or not it's positive or negative. Negative, we're going to move left. 1, 2. And now we're going to put that decimal there. And there it is. So this now becomes 0.0432 Okay? Now I want you to think about a number line like you learned very early in school, where here is the 0, and anytime off to the right, we are in a positive. 1, 2, 3. So when we're moving to the right, we're moving in a positive direction. But when we're moving to the left, 2, 3, we're moving in a negative direction. -1, -2, -3. Okay? If we're moving to the left, we're moving in a negative direction. Okay? So what this number up here tells us is not only the number of place values to go, but in which direction. Okay? This is when you're taking something out of scientific notation and you're actually moving that decimal place. Okay? Now, I want to take a look at another thing that we do, and that is we put things into scientific notation, and so we have to create the code for someone else to use. Okay? So when I give you a number and I ask you to put it into scientific notation, we need to know what it is that someone's going to do when they go to move it out of scientific notation. So 764. This number is not in scientific notation. Scientific notation only has one number in front of the decimal place. This is where the decimal is here. We know this, right? And we have 3 numbers in front of the decimal. We only want there to be one number in front of the decimal. So I have got to move this 2 places to the left, okay? So now I'm going to end up with a number that is 7.64, okay? 0. And what I want people to do is eventually in order to get this number, people need to move it 2 to the right. And so I need to put this here. Now we moved it to the left. So in order to compensate for that, we need to use a positive number here, because we know when we move it 2 to the left, when we want people to convert it back, they're going to need to move it 2 to the right. It's a little bit of a different thought. This is when you're putting something into scientific notation. Now it's quite easy. If I gave you this, you would grab it and move it twice. And there you would have your 764. So when you are creating scientific notation, that's when it gets tricky. That's when you have to really think. The number 87, is this scientific notation? No. We know that 87 is really 87.0, but we can only have one number in front of the decimal place. So what we're going to have to do is create this, 8.7. We can put a 0 on the end if we want. And we've moved it 1 place to the left. But we know when someone goes to move it back, they need to move it to the right. Now you don't need to put a 1 here, but you're free to, okay? And we know that then when you move that 1 to the right, okay? So when you're creating scientific notation, when you're putting a number into scientific notation, put it in there first with just one number in front of the decimal, and then think about how would someone get back to my original number, and that'll tell you whether to go negative or positive. For instance, let's try this number now. 0.45. Okay. Now, I told you before that the number in front here needed to be 1 through 9, including the numbers 1 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 does not count. So this decimal place needs to be moved so that we can end up with 4.5. But we know that when someone needs to move it back, they're going to need to move it to the negative side, right? That this is a negative 1. So to get from this number back to the number we started with, someone is going to have to move that. So the first thing you do is create the number so that one number is in front of the decimal, and then make sure this reflects how you need to move that decimal to get back to your original number. Okay? That's scientific notation in the nutshell. Okay? It's a little bit more tricky to put numbers into scientific notation than it is to take numbers out. Taking numbers out is quite simple. You just move that decimal however many places over based on this. Positive to the right, negative to the left. But when you're putting a number into scientific notation, you start with creating that one digit in front of the decimal, and then figure out what it is that you need to do to get back to your original number. If you have to go this way, it's positive. If you have to go this way to the right, positive. But if you have to go back, it's negative. Okay? It's the opposite. Okay. So now, how does this impact us as we go forward in physics, in what we're studying right now in physics? Okay, great question. In physics, you have been studying wavelength, frequency, and the speed of light, using this incredible equation that says the speed of light, which is a constant, is equal to lambda, this is the symbol for wavelength, and frequency. This is the speed of light, which is a constant. It's always the same. The speed of light is 3 times 10 to the 8th. This is in scientific notation, meters per second. We know that if we were to convert this to a number without scientific notation, we would take that decimal point, which is really 3.0, and move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Oh! Let me just erase this little. I erased too much. 1, 2, 3, 4, 5, 6, 7, 8. And then we would put in all of our zeros. And there's very many of them. And for this reason, scientific notation is helpful, because all of these zeros can be blinding and confusing. And so here we have it. 300 million meters per second. Okay? That's the speed of light. It doesn't change. Wavelength and frequency. So let's draw ourselves a wave, and let's talk about what is a wavelength. These very tops of the waves are called crests, and if we measure from one crest to the next, that's the wavelength. That's the length of one wave. And it is the same if we go to the next crest and the next crest. This wavelength doesn't change. Frequency is the number of waves in a given period of time. Let's say the number of waves per second. This has a lower frequency than this. This has many more waves per second, right? Notice that the wavelength here is shorter. Here you have a long wavelength when you have a very low frequency, and we call frequency F. We have a very high wavelength, which we call lambda. Okay? So let's take a look at this. If I use this equation, I can figure out the frequency or the wavelength if I know one. If I wanted to find out the wavelength and I knew the frequency, I could divide by the frequency here. If I get rid of this, now I'm getting rid of frequency, and divide by frequency on this side of the equation. And now I know this is the speed of light divided by the frequency is going to give me the wavelength, okay? And if I have the wavelength, but I want to know the frequency, I can do this. Wavelength, frequency. I can divide both sides by the frequency to get a formula. This will cross off and this will cross off. That will tell me how to get the frequency. So then the wavelength, the speed of light divided by the wavelength will give me the frequency. Okay? And I know that Miss Marcotte has done some work with you all to take a look at wavelength. Okay? So the wavelength of red visible light is 700 nanometers. So let's look at that. Let's go to our whiteboard. And I'm not even sure that I can get back there. Where is the whiteboard? Okay. Okay, got the whiteboard here. All righty. So now, let's try to get our whiteboard here. Now we're going to use some of the same. It's getting a little dicey in here. Okay, so let's put what we know. We know that C equals lambda, or our wavelength, times frequency. Okay, so now Miss Kathy says that red visible light, okay, has a wavelength of 700 nanometers, okay? There we go. And we know that the speed of light is 3 times 10 to the 8th meters per second. And we want to know what the heck is the frequency. Well, on the slide before, we calculated that frequency is actually equal to our speed of light, which is this value right here, divided by our wavelength. And we know our wavelength of red light is right here. Okay? So let's set up our equation and find what is the frequency of red light. The frequency then is going to be the speed of light, which is our 3, right? This is our equation, is going to be our, 3 times 10 to the 8th over 700 nanometers. Now, here's where the problem comes in. Up above, we're dealing in meters. Down below, we're dealing in nanometers. So what we're going to have to do is convert nanometers to meters. And the way that we do that is to know that nanometers means times 10 to the minus 9. Okay? And there we have it. So now our equation should be 3 times 10 to the 8 divided by 700 times 10 to the minus 9. Okay? And there it is. So if we use our calculator and we do this problem, we do 3 times 10 to the 8th divided by 700 times 10 to the minus 9. We get the answer to be, we're using our calculator, 4.29 times 10 to the 14. And this is going to be our frequency. Okay? That is the frequency of red light. Now, there's some other things that we can do with this number. And it involves knowing how to add and subtract and multiply and divide exponential numbers, okay? So what we can do here with the 700 times 10, first of all, we can convert 700. Here's our decimal place. We want to move it 2 to the left to create a scientific notation. What would I need to do to this number to get it to look back like our original number? Well, obviously we need to move that decimal place 2 to the right. So here's the number that 700 looks like. And then don't forget, we're multiplying that by 10 to the negative 9. Because these bases are the same, we add exponents. And so this ends up becoming 7.00 times 10 to the minus 7. Now, if this all seems very, very confusing, it's because we're not at that point in Algebra 2 where we're going to start talking about exponential functions and how we add and subtract and multiply and divide, okay? So that's probably why this is feeling a little bit difficult, uncomfortable, unsure. That's okay. We're going to get to this later in the year, but just know that if you have your handy dandy calculator that you're going to get this answer, okay? This is going to be your answer. All right? For right now, that's enough. We'll be returning to this concept later in Algebra 2, but the important thing for you to know is that this is the formula for frequency, that this is the formula you've been really using here, and how to use scientific notation. How to get something out of scientific notation is very easy. The directions come right here. But how to put something into scientific notation requires you first to create that number that only has one digit before the decimal place, and then to figure out what do I need to do to get back to where I was. And that will help you decide what sign to put in front of the number. I think that's where most kids get caught up. They understand we're moving it to, but they don't know which way to move it. So what you need to do is look at the number you get from the number you're going to or you're coming from and decide if people need to move to the right or the left to get to this number. I give you 7.00, but what I really want is for you to get to 700. Then you know that those two places have to go to the right. Okay? If I give you this number, 37, that's not in scientific notation. Let me add a couple digits behind it. That's not in scientific notation. To get it into scientific notation, I know that I have to put the 3 in front of the decimal place. But where the 3 really belongs is behind the decimal place. So where do I need to go? If I give you this digit and I'm trying to give you the roadmap on how to get back to here, what you actually need to do is to move this one place to the left. And so I'm going to give you the -1. And this is the scientific notation for this number. Convert it into a scientific notated first number, and then figure out your roadmap looking at your original number. Okay? Thank you guys so much. As always, for questions, let me know.